I am Prabhu Benmarad, Assistant Professor, Department of CHC, BAd ECT, Vijaypur. In this video, I am going to discuss about memory management in C, that is memory allocation. So here I would be focusing on compile time memory allocation, dynamic memory allocation, memory allocation functions. So let us see what is memory management, nothing but memory allocation. The programmer needs to allocate the computer primary memory to store and process the data to solve a problem by using a computer. So every program which executes in a computer requires memory for storing its information. The information of the program, the data of a program can be stored by using following two techniques. So they are compile time memory allocation, dynamic memory allocation. So compile time memory allocation is also called as static memory allocation. Dynamic memory allocation is called as runtime memory allocation. So let us see one by one. Compile time memory allocation, as the name implies, the process of allocating computer's primary memory well in advance before the execution statement, program execution starts. So this is called as what here? Compile time memory allocation. So before the program starts executing, some memory will be allocated for the variables. So this technique has the following limitations. The size of the memory cannot be varied during program execution once it is allocated. Once the memory is allocated for the variables, its size cannot be varied. So we cannot extend its size, also we cannot shrink its size. A programmer cannot create abstract data types using compile time memory allocation, such as linked list, trees and graphs. So linked list, trees and graphs are growing data structures. So it requires a memory during the program execution. So let us consider few examples to demonstrate what is this compile time memory allocation. So in this example, we have declared an array of name marks. The maximum size is 5 and it is of type what here? Integer. And this particular array will hold initial values, that is 80, 60, 70, 85 and 75. So as soon as this statement is executed in a program, a memory will be constructed of 5 memory locations, and each memory location is stored with these initial values. Okay, see here, suppose if I want to store few more elements into this particular memory, suppose if I want to extend, if I want to construct few more memory locations for already which is allocated. So this is not possible in case of compile time memory allocation, right? So here the memory size will be what here? Fixed. It cannot be changed. Neither it is extended nor it is shrinked here. Let us consider another example. Here we have declared an array variable, that is marks, and the maximum size is how much here? 8. So 8 elements can be stored in a memory location. So soon after execution of this statement, 8 memory location will be constructed. So out of 8 memory locations, we are storing only 5 elements in 5 memory locations, and remaining 3 memory locations are what here? Empty. Suppose in this case, if I want to reduce the size of the memory, if I want to shrink this array, then this is not possible, right? So here what happened? The memory is wasted in advance. For 8 elements the memory was allocated. So unfortunately we are storing only 5 elements. The 3 memory locations are what here? Became empty, right? So here 3 memory locations were wasted. So it is not used for storing any information, right? So in this case, suppose if we want to shrink it, it is not possible, right? So in case of compile time memory location, the memory is allocated during compile time and it will be fixed. it cannot be increased or it cannot be decreased, right? And the next is what here, dynamic memory location. So here the memory will be allocated during the program execution. So it depends upon what here, how much memory which is required for the program, only that much memory will be allocated here. So this technique makes the use of the memory allocating functions like Malloc, SeeLog, Realloc and free. So all these functions which are used to allocate a memory during runtime, right? So here what happens, depends upon the requirement of the program, how much memory the program requires, only that much memory will be allocated. In this case we can extend the memory, we can increase the size of the memory, also we can decrease the size of the memory. Here we can prevent the memory wasting, okay? And all these functions, memory management functions, so which are stored in this particular header file or this particular what here, header file, right? So before we use these functions in our program, so we have to include any one of these two header files, right? Let us see one by one. So what is the use of these memory allocation functions and how these will be written in a program for allocating a memory. So Malloc. So Malloc allocates the required number of the memory blocks during program execution and return the address of a first memory block to the pointer variable. So here Malloc does not initialize the memory, okay? So Malloc function, what it will do, it will allocate the required number of the memory blocks and the first memory block address will be returned to the pointer variable, okay? Suppose if we want to locate the next memory location, so we can use, this can be achieved by using what here, addition operation with the pointers, right? So in case of failure of allocation, if the memory is not allocated, if the function fails to allocate a memory, that time it will return a value null, okay? So let us discuss the syntax. So if you want to allocate a required number of the memory blocks, then we have to follow this particular syntax, that is pointer variable, and this is what here, data type, and this is Malloc function and byte size. So how much memory you want to allocate, no, that much size you have to specify here. So the pointer variable is nothing but any valid pointer variable, and data type is the type of the data for which you want to allocate a memory, and byte size is nothing but what here, the size of the memory which you would like to allocate. So let us consider example. Here we have declared a variable, that is pointer variable of type what here, character, and what we are doing, we are following this syntax. So this is data type and Malloc function. So how many number of blocks we want, 5, and size of these 5 blocks are what here, the size of the character. So the size of the character is how much here, 1, so that 5 into 1 equal to 5. So total how many memory blocks will be allocated, 5 memory blocks will be allocated, and size of each block is how much here, 1 byte, okay? So after allocating a memory, the first memory block address will be stored in this particular pointer variable, okay? Suppose if you want to store any information in this particular location, so then what you can do, you can use this pointer variable and you can assign the value. Let us see few more examples. So here we have declared a pointer variable ptr, and what we are doing, so we are allocating the memory of type integer. So this is Malloc. What is the size of the memory, 10 memory locations, and each location, right, so 10 memory locations we are allocating, means 10 bytes of the memory will be allocated, and the address of a first byte will be returned to the ptr variable. Similarly, Let us see one more example. We have declared a pointer variable, and here so ptr equal to this is the type of the data, and total how many memory locations we require for our program, 10 memory location, and the size of each memory location is how much here, 2 bytes. So therefore 10 into 2 bytes, total how much memory will be allocated, 20 bytes of the memory will be allocated, and the first block memory address will be stored in ptr variable. Okay, so let us see a program example. Here we have declared a pointer variable to store the address of first memory block, and this is what here index value, and this is the number of the memory blocks for the allocation. So first we will ask the user to enter the value of n, and the value of n is entered from the keyboard, which is stored in n variable. Okay, so let us assume I have entered say 5. Okay, so 5 will be stored in n. Okay, so next what we are doing, we are allocating a memory. How much memory we are allocating? 5 into size of int. So it becomes how much here, 10 memory locations. So 5 memory locations will be allocated, and each memory location is of size how much here, 2 byte. Okay, so that what happening, the first memory location address is 1000, the second memory location address is starting with what here, 1002, the third memory location address is starting at 1004, right? So here how many bytes of the memory is there, 2 bytes. Here 2 bytes we have. Okay, so after allocating, we are asking the user to enter the information. So first what happens, he will enter say 10 value. So that 10 will be stored in this particular memory location. How we access this memory location? So in IP we have the starting memory location address. Okay, so IP plus I means what is the value of I? So first time the value of I is how much here, 0. So that is 1000 plus 0 equal to how much here, that is 1000. So nothing but first memory location, there the information will be stored. So again it will go back to for loop. So I value is how much here, say 1. So it becomes how much here, in pointer incrementing one time means it will be incremented twice. Okay, in case of the pointer. So therefore it becomes how much here, 1002, means next time the information will be stored in this location, third time the information will be stored in this location, right? So here what happened, we wanted 5 memory locations to store the information. So therefore only 5 locations has been allocated. So we haven't allocated the memory in advance. Okay, so during a program execution we asked the user how much memory you require, and depends upon that much memory locations has been allocated. So this is about what here, Malloc. So let us see about the SeeLog function. So it allocates a required number of the memory blocks during program execution and returns the address of the first memory block. So it is same as what here, Malloc. Okay, so in this case what happens, the SeeLog will initialize the memory blocks with what here, 0. Okay, in case of Malloc, so memory will be allocated, but the memory locations are not initialized. The memory locations are what here, uninitialized. Okay, will be having some garbage value. In case of SeeLog function, the memory will be allocated consecutively, required number of the blocks, and all those memory locations are allocated with a value by 0. Okay, so let us see the syntax. So here the pointer variable, and this is data type, and this is SeeLog function. So n is nothing but what here, the number of memory locations, and this indicates what here, the size of the memory. Okay, so let's consider an example. So IP is our pointer variable, this is what here, the type of the data, and this is a SeeLog function. So how much memory, how many number of blocks we require, 5, and the size of each block is how much here, 2. So therefore what happens, whenever this statement is executed, 5 memory locations will be allocated, and each memory location size will be how much here, 2 bytes, and the content of each memory location is initialized with what here, 0. So you can see the 0 content. Okay, and the starting address of the block is stored in IP, the pointer variable. So let us consider the example. So here what we are doing, pointer variable. So we are asking the user to enter the value of n. So how much memory you want to allocate. Okay, so whenever the user enters the value of n as a 5, then that 5 will be stored in n. And next what we are doing, we are using SeeLog function, and we are passing two parameters. The first parameter is what here, the number of the blocks, and the second parameter is the size of each block. So 5 into 2 means how much here, 10 memory blocks will be 5 blocks will be allocated, and each size is how much here, 2 bytes. So what we are doing, we are receiving the information from the keyboard and we are storing it into each block, and this particular scanf printf statement will display the will read the information from those memory location, and it is displayed on the screen. Okay, so one thing you can observe is here the SeeLog requires two parameters. One is the number of the blocks, and second parameter is the size of each block. Okay, and after allocation, all the memory locations will filled with what here, initial value 0. Okay, so the next function is what here, Realloc. So this is another memory allocation function available in alloc.h. So it helps the programmer to allocate new memory space for previously allocated memory, which is by what here, malloc or SeeLog. Okay, so for example, initially what I did, assume I have allocated 5 memory locations, consecutive memory locations, and each of size 2 bytes. Okay, so during program execution, what I feel, I require another 10 memory locations to store the information. Okay, during program execution there is a requirement. Okay, so in that case what we can do, we can use Realloc memory management function to allocate another 10 bytes of the memory for the previously allocated memory. So we can extend the memory, so which is already allocated. So then how to use Realloc function? So you have to follow this particular syntax, that is pointer variable, and this is Realloc function. So it takes two parameter. The first parameter is what here, previously allocated pointer, so previous pointer variable, and the new size. Okay, so let us take an example. See here, assume we have allocated what here, we have allocated 5 memory locations, and each of size how much here, 2 bytes. So this is what here, old memory. Okay, this is old memory, right? So during execution of program, what I feel, okay, what we require, another 6 bytes of the memory is required, another 6 locations we require, and each of size how much here, 2 bytes. So in that case what we can do, we can use Realloc function. So this is what here, old pointer, this is what here, old pointer, right? So IP comma 6 into size of how much here, size of int. So we require another 6 new memory locations, and each of size how much here, 2 bytes of size int. So therefore what happens, the new memory which is allocated is how much here, that is the 6. So total memory which is allocated for this particular pointer variable is how much here, so that is 11. So old 5 and new memory locations 6, right? So reallocation means what here, allocating memory, new memory for the memory which is already allocated. So let us see last one, that is free. So this function is used to deallocate the memory which is allocated by the dynamic memory allocation functions. So at the end of program execution, we have to release the memory which is allocated by the dynamic memory allocation functions, either by using malloc, SeeLog or Realloc functions. So the programmer needs to deallocate the memory. Okay, so to deallocate the memory, you have to use the function that is free. Okay, so the syntax is you have to just write free and you have to pass the pointer variable which is holding the beginning address of the memory allocation. Okay, so this is what here the memory allocation syntax. Suppose if you want to free the allocated memory, then what you have to do, you have to use a function free and you have to specify the pointer variable. Okay, so all the memory which is allocated by dynamic memory allocation functions, that memory will be released. Thank you. Please subscribe to my YouTube channel to see more videos on C programming.